T-shirts, please.
We're all go. All systems go over there. The treasurer says action. So we will do. Good evening, ladies and gentlemen. It's going to be one of those audiences. Yeah, you're going to have to be a top here. I'm observing it. Yes, good evening. Tonight, first, hopefully a nice series of talks. We're working on trying to think of some good ideas for guest speakers and talks on maybe regular Wednesday nights, something along those lines. So if you've got any ideas, go for it. Throw them at us. Cyber security, you've made me think about already. Thank you for that. It's a good idea, pinch it. Let's play. So tonight we have Chris Elcock from
East Kirby, the museum. So, evening all. I'm going to bore you to death about Lancasters and restoration, rivets and all that kind of stuff. So a little introduction about myself. So I did 26 years in the Air Force. Started off as an airframe technician, then got cross-dressed, multi-skilled into engines as well. So I did Typhoon, in the early days I did BBMFs, I did 3 years on BBMF, working on the Spitfires, and the Lancaster, and gallivanting all around the nice air shows and all that kind of stuff that you do. On leaving the Air Force, I found a job at East Kirby, doing the restoration work on Just Jane, and that's where I am. I've been there for just over 3 years now, doing that. Learned a lot while I've been there, so some of the stuff that I was taught during trade training in the Air Force, you don't get taught, they don't teach that anymore. Riveting, all that kind of stuff, you learn when you're in the Air Force, but they've stopped doing that, obviously carbon fibre aircraft, helicopters, telephone. So yeah, so that's a little brief history of me, where I've come from and where I am now. What I'll do now is I'll start talking about Just Jane, a little bit of back history. So they got the aircraft, they paid for the aircraft, bought it in 1983. They couldn't get it the first time round, but the sale fell through. They got it in 83. And then eventually started looking at dismantling it from Scampton's Gate Yard and moving it down to its current home here at East Kirby in 96, 97. So anyway, they got the aircraft, and obviously a couple of ex-BBMF engineers decided to get involved, trying to get an engine running. So that's what they did. Spent a few years, got an engine going, and then obviously it grew legs, and before you know it, number 2 engines running, number 3, number 1, before you know it, they've got all 4 engines going this week. So that's what they did with it, and they started taxing it around, and as you see on the photograph down there, roofing it across the grass, getting the tail up and having a little bit of fun. 2016, so they decided they wanted to do a survey on the aircraft. Needed to do that, obviously got to take all the paint off. So you may have seen pictures on the internet. Around about 2016, 2017, they literally paint stripped the whole aircraft. It was literally burn metal. So they could assess it, get a fresh coat of paint. It was a good idea. Some of the methods of taking the paint off probably took some of the material off, some of the skin panels. So obviously a skin panel on an aircraft, if you've got corrosion in it and you get 10%, more than 10% depth of corrosion, then it's generally US, whether it's a skin panel or any bit of structure really. It usually means it's US. So when it was sanded back, just to take the paint off, it was a little bit. They weren't sure of how much metal they took off when they were taking the paint off, which led us to where we are now. We're doing our restoration. The majority of the skin panels on the aircraft are going to get replaced. You normally find that when you're taking them off anyway, if it's had a rivet formed in it, when the rivet gets scores and reacts and expands, it expands the hole anyway. So 9 times out of 10, if you drill the rivet off and took a skin panel off, all the holes are probably oversized anyway. So that's what happened anyway. They stripped the aircraft back, and as a result, they decided that they were going to replace all the skin panels. So, French Lancaster crashed in Wallis Island, 1963, I think it was. NX664. French operated aircraft. That had an issue on the runway, came into land, went off the runway, damaged the aircraft, and the French decided, let's just leave it. So they left it in London. So this thing sat for years, for decades, just neglected. And the villagers, the locals on this little Pacific island, Wallis Island, they didn't vandalise it, but they liked to throw stones at it. So this thing was full of dents and it was damaged and it just looked derelict. The French then decided that they wanted to recover this aircraft. So that's what they did. Took it all apart, put it on barges, took it across the sea, brought it back to France. And they did a sort of sympathetic restoration to it, should we say. So if you put a dent in it because somebody's thrown a brick at it, what they did is they went on the inside, knocked the dent back out again. But sometimes when you're knocking the dent back out, it ends up bulging on the outside because the metal's stretched. So you can't you've got to shrink it to get it. So when we got the nose section, it was covered in dents. So that was one of the first bits that we got from the French. It was a wing, port wing, and the nose section. And what their plan was is they'd struck a deal up with the French organisation that what we would do is we'd sympathetically restore their Lancaster, and then any bits that we restored, we would use purely just for taxiing. So say the nose section, which is one of the first bit I ended up doing, the French nose section. Sympathetic restoration, reskin only the skins that needed reskinning, repaint it, fit it all out with the bomb aimers equipment, obviously bomb computer, bomb sight, all that kind of stuff. Fit it all in with that, and then what we did is we took Jane's nose section off, fitted the French nose section, spread it in the RAF colours, it should be, black and brown and green on top, and then obviously the Jane taxis ran down with this NX664's nose section fitted to it. So that's the plan of where they were going with the aircraft. So when it's finished, when we get the nose section of just Jane, so we took ours off, and I'm restoring that to airworthy condition, so that's all new formers. I'll talk about the process of that in a bit. All new formers, new skins, put it all back together again, take the French one off, put ours back on, and then the French get their nose section back. So you can see what's going to happen. It's the same with the left wing. So we did the same with the left wing. Eventually, when it's all done and dusted, the French should have a complete, restored, static Lancaster. It's ideal for a museum. It'll be complete. It'll look quite good, actually. And then what we'll end up with a fairly new Lancaster when we finish. So practically all we've done with just Jane. Some of the majority of the components on it will all be brand new, so it'll look like a brand new aircraft, which is ideal if you want to go flying it. So anyway, I'll talk about the nose section that I mentioned earlier, and then we'll go on to the wing and all that a bit later. So when the nose section turned up, it was painted blue, French markings, full of dents, it was all damaged, and I'd literally just turned up at East Coast. This was 3 years ago. I literally just turned up. And they said to me, do you fancy having a go at this? Now bear in mind, I'd just come off Typhoon. Typhoon is a carbon fibre aircraft, fly-by-wire. It's quite a modern jet. So I'd come off that, went straight onto this nose section. And I said, well, what is it exactly that you want me to do with it? He said, well, do a sympathetic restoration. So anything that you see damaged, replace. And there's formers in. So is anybody familiar with formers and stringers and that kind of stuff with aircraft? Right, so I'll brief. Imagine if I took the skins off or any part of an aircraft, it'll have ribs and it'll have stringers. And it's like a rib cage basically. It's like a bird cage sort of effect. So you'll have verticals and you'll have longitudinal ones that run this way, and obviously they're all held together by little angle brackets. And you're making like a cage affair sort of thing. And then what you would do then, you would skin over the top of that. Now when you're making this cage affair, some of the structure of it has got to be curved. Some of it's straight. If it's straight, but it's doddle. You can get straight bits of metal and it's easy, but when you start talking complex curves and double curves, it becomes a little bit more difficult. So when I started doing just Jane's nose section, it had all these formers inside, and basically what formers is, if anybody's ever seen a model aircraft that's not got it covered on it, you can see it's all ribs and all that kind of stuff. That's basically what it is. It's formers and stringers, long drones and all that kind of stuff. So a lot of these were damaged, but they weren't damaged to the point that they couldn't be used for taxiing. So what I did is I just put little repairs, just up where they'd split and cracked. I just put a little repair in it, and that would suffice, that would do the job to get the nose section ready for it to taxi. So I started doing all the nose section with it, making the repairs and the formers. But the difficult bit, is something I've never done before, is when it come to reskinning it was complex. It was like double curve. So imagine when you stand it on its end, like you take it off the aircraft and do that with it. It goes like it curves that way, but it curves this way as well. So when I was getting sheet metal, what I had to do, I had to roll it, curve, I put it through a roller to roll it that way to go around, but then it had to curve that way as well. Do you know what I mean? So I'm like, well, if anybody ever gets a curve, anything curved like that, and then you try and bend it that way, it doesn't want to bend. It's having none of it, you know. And I was like, oh God, I'm going to do this. And there's a couple of guys there. So there's a guy called Keith. I don't know if you've ever seen Nev's videos. He does a few updates on it. And Keith said to me, he says, well, what you need to do is we have a shrinking machine. And what it does is when you put a curve on a piece of material like that, and you want it to curve that way, what you have to do is on these edges, you've got to shrink it. And basically all it is, it's two sets of jaws. And they sit like that. And when you put your metal in it and you pull down on the lever, they pull in, but they grab the metal and they pull it in. It's basically like making pleats. That's what it's doing. And then because it's pleating it, it's shrinking the edge and it makes the metal start bending over. So I thought, oh, I'll give it a go. So I gave it a go and lo and behold, it worked. There's a couple of cock-ups, like, along the way, but I was learning and I managed to get the hang of it and I managed to make the skins. So that was a new thing I'd never done before, using shrinkers and stretchers to shrink and stretch bits of angle iron and aluminium and that kind of stuff. So that's how I started making the skins. So I did get all the skins made, that was all good. And then it come to fitting it all out then. So the winter, we were due to do it, the winter I was due to do it, was 2024, I'd say 24. I was due to fit this nose section to the Lancaster, but obviously the chief engineer said, well, we need to get the left wing off as well, because Keith had just finished the left wing, the outer section of the wing. He just finished that. So in the end, they ended up taking the nose section off, fitting the French nose section that was now painted in RAF colours, fitted that on, and it was quite a simple join. It's like, like modern aircraft now are all assembled in sections. They're assembled in sections like Airbus and Boeing and all that kind of stuff. They'll get a section, build it, somebody else will get another section, build it, and just put it together. And the Lancaster's the same. So a Lancaster's like, for the fuselage section, there's like 5 parts to it. So you've got the nose, you've got the bomb ends at the front, you've got the cockpit section, you've got the centre section, which is not very, it must be only 6 foot in length. The actual centre section, that carries the 2 spars, the front spar and rear spar. And the majority of your systems go through like your pneumatic system, fuel system, engine controls. So it's quite common, although it's not the biggest part of the aircraft, it carries nearly all the systems, quite a complex bit really. And then you've got the centre rear section, which is the bit with the turret on top. So I don't know, you can probably see on that picture. And it's got the H2S dome, you see the dome underneath? So that's the H2S radar that sits underneath. So that's that section, and then you've got the tail section. So, got the nose section done, and then obviously I moved on to Keith. So Keith was doing the left wing. The left wing came off the French Lancaster. It was all corroded, damaged and all that kind of stuff. And he did exactly the same thing that I've been doing. He assessed it, done a survey on all the panels and all the ribs inside the wing that gives it profile. And once he'd assessed it, like, we need to replace this and this, just systematically went through. And he did it on his own, to be fair. I mean, a lot of the work he was on his own doing it. It took him just shy of 3 years to get it done. But he's on his one bloke, right, you know what I mean? But he did it, and then when he come to it, like I said, Christmas 24, then we took the wing off Just Jane. I'd never done that before. A lot of the lads had never done that before in the hangar. This was all new to us. We had to get gantries manufactured to support the wing, and then obviously get formers made to sit in the trestling point so we could lower it down onto the floor. Got the wing, and then obviously Keith wheeled his wing down, and we were like, all started laughing and joking, thinking, it's not going to fit this thing, it's like a big banana. But it went on sweet, Offered it up to the aeroplane, stuck the bolts in, put an engine on it, put the trailing edge of the wing back on, worked a tree. Same with the nose section. The nose section is just a massive ring of bolts. There's a rib, there's a former runs all the way around the nose section, and it's got another former actually on the cockpit section, and they just line up. You line all the holes up, shove bolts through, tighten it all up, and that was the nose section finished. We dropped the turret in it, the turret fitted fine. We got the turret off Jane's original nose section, put that into the French one. Same with the bomb aimers, got all that done. And that was it. So that was the first one, two of the first bits that we got done really, was the nose section and the left wing. So where we're at now is we've got the original left wing off Jane. So obviously it's now fitted with the French left wing. There's no such thing as a French Lancaster because they're all British Lancaster, French operating aircraft. So it's got the French wing on the port side, and obviously it's got the French nose. So Keith at the minute is doing the port wing, making a new one. So he dismantled the original, laid it all out like he did with the French one, and then assessed everything, all the component parts, and decide. You've got to assess them and say, right, well, that's serviceable, that just needs deoxidine, which is a corrosion, it neutralises corrosion. Deoxidine it, give it a surface treatment, primer, and then we'll use that again. So a big pile of stuff we're going to use again, and then we get the new stuff. So the new stuff we got for the wings, quite an important part of an aircraft, any aircraft really, is the spars, the wing spars. It's the primary strength of the wing. So you've got a leading edge spar or a front spar of an aircraft, and you have a trailing edge spar, rear spar at the back. So you've got two uppers at the front, two lowers, and then it's basically once you've got your top spar, your upper and your lower, you put a web plate on it. It's similar to a girder then. Imagine a girder, an RSJ. It has that sort of properties to it. It gives it a lot of rigidity. A little bit flex because you need it for an aircraft, but it gives it a lot of rigidity. So that was it. So we got the material for the front span. It was quite a challenge really because obviously a Lancaster, this aircraft was made in 1945. So it came from Longbridge, Austin Motors, I think built it in 45. So you can imagine it's an 80-odd-year-old aircraft. And it's been around, it's flown to Australia and back, and it's done a few bits and bobs. But you can imagine the age of it now. So the spar material that it was made out of back in 1945, you can't get that material anymore. So you need to source a modern equivalent for spar material. Once you've sourced a modern equipment, then you've got the CAA, which is the Aviation Organisation Authority. They've got to sign it off. And these things these things are not done over a weekend. They take months to source the material. Is it the right specification? You've got the right hardness and tensile strength. And then once you've found it, then you'll offer it up to the CAA and they'll say, yeah, that's suitable material. Then you can start looking at ordering the material. I think the material came from the States, I think, in 30-foot lengths, and it was basically, it was a billet of aluminium. It must have been that square, 30 foot long, and it's got to go through a machine. So because the spars have got so many holes drilled into them for brackets, for the skin, for numerous stuff, you can't copy it by eyeball. You couldn't go on tape measure. Right, that's 6 foot, so I'll drill it all. So what they do, they send it to a company, I think it's got a company in Lancashire. And what they've done is they sent the material up to Lancashire, they'll copy it. So basically they'll put it through a machine that will machine it exactly the same as the original. And then it'll copy drill it as well. So it'll pick up all the holes as well. So when you get it back from it, it'll be a brand new spar. And that's the life of the aircraft really. And a lot of people say, well, will it fly? We get asked this question daily at work, when we get people coming in and having a look around. Will it fly? When is it going to fly? These sort of questions. It will fly. You look at the amount of investment that's gone into it up to now. All this money on materials, especially for the wing. You've got to fly it. That's what the whole game is really. How long it's going to take is anybody's guess. We'd like to say probably another 5 years, but thing is with an aircraft such as that, that's so old, you don't know what you're going to find until you take it apart. And because the aircraft, because you want to taxi it in summer, maintain it and do work on it through the winter, you've only got a small window where you can, does that make, do you know what I mean? So if we said this year, this winter, we want to take the rear centre section off. So that's a bit behind the trailing edge of the wing and about 6 foot in front of the tailplane. So we want to take that bit off, quite a big piece. So Jody, who sat behind you, and Dave Moulds, who's another structures engineer at East Kirby, those two are getting on with that. And it's a French section, it's off the French Lancaster. So the aspiration is this winter is to get the aircraft on trestles, all 4 engines off, get it jacked up, fold the undercarriage up and lower it as low to the ground as you can get it. So it's in what they call a rigging position, so basically it's level. Yeah, get it in the level position, trestle it, and then what we're doing is literally splitting it to 3 pieces. So you'll have the wings and everything in front will be one bit, and then the centre mid section, or the centre rear section will come off. The bit that Jordan and Dave are doing, that'll get fitted, and then that section then will go into our jig, and we'll start dismantling it. And we're basically just doing what we did with the nose section, and what we've done with the wings. We'll start taking it apart. Same deal. Thing is, with that part of the aircraft, a lot of the formers, because it's over the top of the bomb bay, it's quite a substantial bit of structure. A lot of formers, a lot of material in it's quite thick. So, it's quite heavy duty stuff. So the chances, fingers crossed, that there's not going to be much wrong with the actual structure itself. Get it paint stripped and have a look at it. As long as you're quite careful drilling rivets out and stuff, you're fairly straight with the drill when it comes to taking it out. There's a good chance that the majority of it, by the skins, can be kept. And hopefully it'll be a big re-skinning job, and then it'll go back up. I think it'll go back up. It just depends on when we need to give the French that bit back. You know, ideally, what we would like to do, keep the nose section fitted that's all, put the nose section that I'm doing now that's nearly finished into storage, like we've done with the back end, and just leave them, cover them up, leave them, so that when the aeroplane goes back out taxiing, all the people that are getting in and out of it and climbing in and out, they're not clambering in and out of an aircraft that's just been restored. Because you can't, people that work around aircraft, especially old aircraft, you know where you can put your feet up and grab hold of them. But you can't expect everybody to know that, especially when they're just coming for a taxi ride and you start getting trampling all over everything and stepping on this, and then before you know it, you're back into the business of repairing something that you've just restored, haven't you? You know. So that's where it is at the minute with its progressive, how we're taking bits off, putting the French part on, restoring our square with it, and then obviously doing the swap back, but it all focuses around summer, winter, because obviously it needs to taxi, just to raise money really. And that's what it's for, it's raising money to keep it taxiing. So that's the plan for this winter. When I go back, when I look at the nose section now, so the nose section I've just done, as opposed to the French one where I just did a sympathetic restoration, the nose section I've just done is all new. There's probably 3 components in the whole nose section that's original. And that's not because we just want to throw stuff away, they're quite substantial bits, and when we assessed them, they didn't need replacing. So everything else was corroded or it got damaged, so I ended up speaking to Dave Moulds, who was working with Jordan on the back end, about making formers. And what we ended up doing, so a lot of this material that's made on the aeroplane would have been done mass scale. You imagine how many Lancaster were turning out in a month, and everything was put through a press. You know, you had T0 material, which is not heat treated, which you can just bend with your fingers, and you could put all this stuff in a press, wang, or even if it had any heat treatment, bang it into a press, and it would come out perfect, like a car body panel. Just bang them into a thing and off it went, you know. Whereas we don't have that luxury of having all these presses. So it meant that we had to make jigs for everything. So what we were using, we've got some, we used to call it Paxlin, think it's called Tufnell, though, isn't it? Is it Tufnell? And it's like it's a composite material. We're using a resin. It's really hard stuff, and you can make shapes out of it. So what you do is you get a former out of the aeroplane, de-rivet it, take a former out. It's basically like a U-channel, but when you look at it, if you looked at the aircraft from the front, it's what gives it its shape when you look at it from the front. So you take one out, and we had to make new ones. So what I ended up getting this material, jab rock, that's what it's called jab rock. And you have to make a template with the original. So what you do is you get your big piece of jab rock material, or piece of wood, so put your former on top of it, draw around it. It sounds a bit rough, doesn't it? Draw around it, doesn't it? Draw around it, do I hate working with wood. We started off making wooden ones, I tell you what, I could have lobbed them through the window. Oh, not funny. So I made it out of wood, and you would put your former on top of it, and then where it would fit, you'd be fine. Then where it didn't fit, right, shave a bit off, and be backwards and forwards to the belt sander, take a bit off, try it, and fit again. Then I just do my boxing. Because some of the formers, because it's the curve of the aeroplane. Imagine if you looked at it in sectional wise, it'd be 90 degrees on the inside of the aeroplane, then when it went to the outside, it'd curve that way, or sometimes it'd curve that way. Or sometimes it'd do all three in a one as you went round it to go like that. And then, so I'm trying to make a piece of wood to do this, and then try and fit this thing in it. So once I put the piece of wood on the former, and it fits inside the former perfect, I know that if I take it off, throw the old one away, cut a new piece of flat metal, drop my piece of wood on it, bolt it to it, and then knock it round the wood, it should come out the same shape, shouldn't it? Should do, shouldn't it? So obviously you knock it round the piece of wood, and as you're knocking it round the wood, eventually it'll make the same shape. But the thing is, when you start knocking, if you had a straight piece of wood, imagine that's a piece of metal, and I want to make that, I put my piece of wood on it, and I knock it round. When I finish knocking it round, it's going to be the same shape as what I've knocked it round, isn't it? So that's basically the principle of it. So I ended up making all these formers, but when you knock a piece of metal over that's on a curve, and you want to knock the outside edge up, and you want to knock the inside edge up, as you're knocking the outside edge up, as it knocks it up, it makes a metal bend. So when you knocked it over, you think, oh, this is champion, this is going round knocking it all over bit at a time. And then when you take it out of the piece of wood, because it'd be sandwiched with two pieces of wood, when you take it out like that, what a banana like. So I said to Dave, I said, it's gone like a big banana, this thing. He said, yeah, you need to shrink it. And he said to me, he said, always think of it as when you're knocking it over on an outside curve, knocking the metal over. So when I'm doing, that's a flat bit, when I want to knock it over like that, on a straight piece of metal, it'll just knock over 90 degrees straight. But if it was a curve and you knock it over, it's a radius. Imagine you've got a centre and you've got a circle, and you've got a piece of metal here, and you want to knock this over. As you're knocking it over, the radius has now got smaller because you've knocked it close to the centre. You end up with too much material, and it puts like a ripple in it, like a pie crust. You know, that's what it does to it. It makes like a ripple into it. So when you look at all these ripples, that's when you get your shrinking machine. You remember the jaws one time, it grabs the metal, and as you pull the lever down, it grips it and pulls tight. What that does is it takes all the little ripples out of it. So as it takes the ripples out, it starts bringing the metal back up. The reason it's rippling, there's too much material, it's got nowhere to go. So because it's got nowhere to go, it says, well, I'm going that way. And it just makes the metal bend. When you start taking all the creases out of it, it all comes back up straight again.
Can I just ask you a question while I remember?
What?
Is this how they built them in the first place?
No. Like I say, what would have happened normally, they would have had a press.
And that would have taken all the stresses out?
Well, I would say that it would have been T0. So it's really soft, isn't it? So T0 material aluminium. It's literally, you can get 40 thou thick T0 and just grab it with your foot and just bend it. Whereas if it's T3, it's got an heat treatment to it, you've no chance. you might get a little bit of a bend on it, but that'd be about it. So you find that, I mean, I've not looked it up, I've not Googled it or anything like that, or looked in any books, but I'd be a safe bet to say probably T0, because if you wallop it, and it's got an heat treatment to it and lift it off, that metal's got to go somewhere, hasn't it? And if the metal's got an heat treatment to it, it's going to struggle. So I would have thought it would have been, I mean, somebody might be correct us on that, but I would have thought it was T0 and you should stick it in an oven, because they would have had massive ovens, you could just heat treat it. Once you've heat treated it then let it cool naturally, and it'll age hard, and then we'll give it its tensile strength. So that's basically what, so I ended up shrinking and stretching metal then for it, just keep going on and on and on. And when I spoke to John, who's the deputy chief engineer, I said, John, I said, how many of these formers you want me to change? And he says, no, I said, just do all of them. You know what I mean? I thought, good. So yeah, so I got fed up with wood, and jigsaws and all that kind of stuff it would do, Mark. You know. And then obviously they went out and bought some Jablock, which is this resin bonded wood sort of material, and honestly it's fabulous stuff. You know, when you go from working with like a, not chipboard, but plywood, when you start working with like a relatively cheap plywood, and you make a massive former, and then you put you make a template, shall I say, you put your former on it and you start hitting it, your new one, you start hitting the wood round, hitting the metal round, and bits of the plywood popping out the holes, you know, it's literally coming apart as you're hitting it. Once a bit of the plywood comes out and you try and bend a piece of metal over it, when you hit it with the hammer, the plywood gives away and goes like that, and the metal follows it. So we ended up buying this Jablock stuff, and you don't get any of that. So we've started using that for all the wing sections and all the nose sections and stuff. So that was it. So that was my introduction from Dave. Reference shrinking and stretching metal. So that was that bit. So I managed to master that. So I've done all that. So all the formers are all made. So the nose section now got all new formers in it. I've put all new skins on it. So I've used the rollers. I've even had to go at the English wheel. Never used one of them in my life. Got on YouTube. I got YouTube out. I thought, how am I going to put it up? Because I had to put a bulge in. I had to get a panel. It was a floor panel that went on the inside. And I thought, God, I need to put a bulge on it on the inside to form the contour of the inside of the rib. I thought, I've got no idea how to do this. So I went on YouTube, and lo and behold, there's blokes out there, women out there that have done it. And yeah, you just put it through the English wheel, set your tension on it, roll it a few times, and you can actually see the material coming up, bulging up, and fitted a tree. So I've learned some new things, you know, shrinking, stretching, English wheel, all that kind of stuff. So that's where I... Say again?
Sounds like physiotherapy.
Oh, it's better than working with wood, jigsaws and all them routers and all that kind of malarkey. Oh no, rotten. So anyway, so that's where I'm at. So the nose section's more or less nearly done now. So the material for the wing that I mentioned earlier, so that's gone away, that's getting machined. Keith's doing all the ribs, and there's quite substantial ribs in it. So in the wing of a Lancaster, you've got 3 fuel tanks. 3 in each wing, so it's the number 1 to 3. So you can imagine the inboard tank, which sits in between the fuselage and the inboard engines, is a massive tank. You know what I mean? So that's your number 1 tank. Then you go over the engine, in between the engines, you've got number 2 tank, port starboard, and then on the wing tips, you've got an outboard tank. I think it holds 100 gallon tank, the number 3 tanks. So when it comes to doing the wing structure, all the structure inside is all beefed up, you know, to support the weight of the tank. So that's what Keith's been doing. There's Keith and Josh, so they're doing that at the minute. So we'd like to think that by the time the material gets machined and gets copy drilled and comes back, majority of the stuff will be ready then to start riveting it up and actually get it in the jig. We've got a jig built at work. We can put the wing in the jig and then obviously put it all back together. Exactly as it came off. You're all familiar with jigs for aircraft and stuff like that. Yeah, so you put a component in a jig and then start taking it apart, and then obviously when you rebuild it, fits back in the same jig. You've got the right washout on the wing, or you know, I need to put it back how you found it, sort of thing. The problem I had with the nose section is they don't have a jig for it. We didn't have a jig. So what ended up happening? So the nose section, the jig for it, I've only ever seen a picture of it. It's like a Christmas tree. So imagine a Christmas tree, all folded up, it stands up, see, that's bolted to the ground, and then arms come out, all different places. And then you build your nose section around this jig, clamping stuff to it, gives it its shape. Once you've built it, and you've got enough structure around it to support its own shape sort of thing, then you can unbolt it, fold it all up, tack it out through the top. So when I was doing Jane's, we didn't have a jig, so I ended up, I couldn't take it all apart, I couldn't dismantle it completely. I had to take little bits off, make a new bit from the old bit, and then put the new bit on, and then work my way around. So you can imagine I've took that north section apart around about 1,000 times, you know, taking a bit off, put a bit on, put a new bit on, taking another bit off, and that's how I had to do it, just to stop it getting out of shape sort of thing. That's what I was trying to do with it. So that was that. So, next bit that they're on with at the minute is the tail planes. So the Lancaster at the minute is taxiing now with the horizontal stable, horizontal tail planes. They're off Beaver Lancaster, PA474. So they kindly donated them to us for us to use them so that we could get ours restored. So 18 months ago, a jig turned up, 2 jigs turned up, port outside of it. We ended up getting Jane's tail planes off, Jordan and some of the lads. They took the fin and rudders off the aircraft and then obviously took the tail planes off. We put them into the jig and then started just doing what we did with everything else. De-riveting everything, dismantle it all, and then categorise what we were having. The decision was made that we were just going to replace everything. Underneath the aircraft, so what you normally find is, you know tucker pop rivets, you use a tucker pop gun, they're like you just stick it in the hole, it's got metal what's in, put the gun in it, pull it. Solid rivets are ideal for when you can get to both sides of the job. Riveting 2 pieces of material together, especially a wing skin or a fuselage skin, you've got somebody on the inside, somebody on the outside. Drill your hole, put your rivet through, somebody's on the back with a steel block, reaction block, and then you would set the rivet. See what you can do it. When you start doing like, you can imagine, if you did the top of a wing, and you did all the solid rivets, when it comes to putting the lower skins on, nobody can get to the other side of it, so they're all tucker pops. So underneath the tailplane, they're all tucker pop rivets. Well, tucker pop rivets are quite brutal, really, especially if the skin's fairly thin. And taking them out is even more, it can be difficult taking them out. So that all the lower skins, when we took them off, these skins have been on and off this tailplane a few times. It looked quite rough. So they said, well, we're just going to replace everything. So the tailplanes that are fitted are off Beaver Lancaster. Ours are now on the racking. All the ribs have been made. There's a guy called Dennis that worked at East Kirby. He made all the ribs for it, all brand new ones. So that's ready to go. So when we get the material back, these are the things that we can start progressing. You know, I know what's going to happen. It's all going to turn up all at once. You'll end up with big wing spars, all machined, all ready to go. You'll have tailplane spars all ready to go, and then they're like, God, where do we start with all this lot? You know what I mean? Because it will be, won't it? That's what it'll be like. So that's the tailplanes. So no section, you know where we're at. I've nearly done them. I've nearly done those. The one off Just Jane. So the French one fitted. Left wing, French one. The other one's being restored now, waiting for the spars to come back. What we've got on next with, so George is doing the rear centre section. Next sections after that, I've mentioned earlier, would be the actual centre section itself. And that's the bit that carries the spars. So if you look to the Lancaster from the top, in plan, you've got the 8 wings with 4 engines on. The outboard engines are fastened to the outer wings, and the inboard engines are on the inner wings. So just outboard of the inboard engines is the join. If you looked at Lancaster from the front, it does that. When it goes to the dihedral, i.e. the wings are pointing up, that's where the join is. So the centre section has the inboard engines, The number one fuel tanks are in them, port and starboard, and then that's where you've got all your systems. So you've got your hydraulic systems. So on the Lancaster you would have had hydraulics for bomb doors, undercarriage, and all the turrets would have all been hydraulically operated. So you can imagine the fuel pumps, the hydraulic pumps, all the associated selector valves and pipe work that goes with that. All that's going to have to get assessed, taken out, looked at, same with fuel. The engine controls are all chain and cable. So you've got cables and rods and turnbuckles. So that's where a lot of your engine controls. A lot of them run from the cockpit down into the bomb bay, down the bomb bay, and then they shoot off left and right then and go into the wings of the controlling your engine controls, propeller controls, all that kind of stuff. So that'll be the section that when it started, that'll be taxing. I don't think we'll get I'm not sure we'll get a section from the French that we could just put into it like we have done with the nose or the tailplane, because so many so many systems run through it. It's not something I don't think you could probably just swap. In a winter period, should we say? Our winter period. Normally we have bonfire night, beginning of November, and then that's its last taxi run. Once it's had its last taxi run in November, then the lads take it outside. They'll do some performance runs on the engines, write down all the figures, boost figures, RPMs, all that kind of stuff, temperatures. Then they get saved then the aircraft will go through its maintenance. Now whether that involves taking a component off or just going through routine winter maintenance, like checking your engines, your oil filters, changing the oil, all that kind of stuff. It could just go through that, and then obviously it's back online then for around about back end of April. So if you think about it, November to April seems a long time, but when you've got a lot on, especially this winter, when you start splitting the aircraft down, that's all 4 engines off, 4 propellers, 4 engines. And you're splitting the aircraft into 3 pieces, to swap all these bits around. It doesn't seem a long time then, it seems like you're up against this whole thing, because it's got to be ready for April, back end of April, for starting the taxi season, so that because a lot of people pay a lot of money to get this aircraft, to get on it and then start taxing around on it. So that's where we are, restoration-wise. I think there's a few years left in it yet. How many? Like I said, I wouldn't know. Like I said earlier, you take something off and you might think you could take something apart and not have to replace anything. And lo and behold, you take some skin panels off and it's just a sea of corrosion and everything's got to get changed. So that's how it is. And that's what we tell people too when you come and see us. We say,
can I ask you what materials you were talking about? Corrosion treatment. What exactly is that? Because traditionally the Romans would have used linseed oil, wouldn't they?
Well,
Forth Bridge, etc. But that's a bit old hat. Would that still be relevant?
No, well, see, the stuff that we use is purely it's obviously aluminium. It's different from ferrous metal.
Yeah.
You know what I mean? And it goes powdery. You can get intergranular corrosion, all that kind of stuff. But really, it's down into the metal. But the stuff that we use, it just looks like water. You just rinse, you just get as much surface corrosion off as you can. You can't get
chemical reaction.
Chemical reaction, exactly, yeah. You get as much of the corrosion off you can mechanically, and then you would deoxidine, it's called. You would brush this on, leave it for about 20 minutes, and then just rinse it off to neutralise it with water. Dry the material, assess it again, have a look at it, and then it's ready for etch primer, and then you can paint it. So that's what we've been using. We've used deoxidine. It doesn't smell too nice, but it does the job, and that's what we use for neutralising the corrosion. The thing is with this aeroplane, like I mentioned earlier, it's 80 years old. All the rivets in it all need replacing. In every single rivet in it all needs replacing. So because they were magnesium alloy rivets, and they're 85 years old.
How many of them then? Have you counted them?
Oh God, what I would say, if I was a betting man, I'd say about 20,000, no, maybe more than 20,000, you know what I mean? I reckon in it. So, and what we found with this as well is when we start de-riveting it, start taking the rivets off, so you get some countersunk rivets that are flush with the surface for aerodynamic properties. Some of you might remember the Spitfire. You know, they decided where they would put countersink rivets in it for aerodynamic efficiency, and where they could get away with not putting countersinks in because of the machining process of countersink and that kind of stuff, where they could put mushroom head rivets or snap head rivets or cheese head or whatever you want to call them. And then, so you'd have flush rivets in some places and mushroom dome head rivets in other places. What we found with this is, regardless of whether it's a countersink or a mush head rivet, some of them, the idea of taking a rivet out, some people can just go straight in it with a drill. Some people are a bit more cautious. What they do, they get a little sharp punch, a little sharp centre punch, put it right on top of the rivet, the dome rivet, just put a tap on it, just gives you something for your drill to bite into, and then you would drill into your rivet. Drill just below the depth of the head of the rivet, ever so slightly, and then once the head comes off, you can just tap the rivet out 9 times out of 10. What we were finding with this is when we were taking some of the rivets out, you could put the drill on one and you would drill into it like you drill into a new rivet, but the rivet next to it looked exactly the same. Straight away as you touched it with the drill, it just literally just turned to dust, and you'd be left with a flush. It'd just be a grey circle where the rivet was. The stem of the rivet would still be in the hole, but there'd be no head on it, and it's the head that's keeping it all together. You know, and that's what we were finding when Jody and Dave were doing the rear centre section with some rivets. And they're like 360 rivet, they're quite a chunky rivet, you know, and they're all the ones that run a longeron that runs down the bomb there. So they're quite chunky rivets because it's quite a substantial bit of the aeroplane for carrying bomb loads. And when they were drilling into it, they'd drill into it and then get a punch, parallel punch, just tap it to knock the rivet out, and they'd just a shock of tapping that rivet, knocking it out, the head of the next one would fall off. You know what I mean? The head of the rivet would just pop off, and you think. So when you think, oh, they've got 6 or 7 rivets to it, there's all the place. As you hit it, oh, there's another one. Oh, there's another one just dropped on. Before you know it, you've got 50 to do. So you can imagine if you put this down the grass, and put a little bit of aerodynamic load on the wings, well, there might be a few rivets popping off all over the shop. You know what I mean? Might lose the odd panel. So yes, every rivet, it's got to be replaced. And because you're taking all the rivets off, you've got to drill them out. Then sometimes you incur damage to the panel or the structure underneath, whether it be a stringer or a former. You start taking them all off, and because it's literally all got to come apart, and they'll all get put back together again. You know, if it was a simple case of just de-rivet it and then re-rivet it with just new rivets, and not, would be a lot further down the road, but it's not as simple as that. So you find that you've got to take every rivet out and redo it all, but replace components as you go on, because things with an aeroplane like this, what I noticed on BBMF long time ago, is the aircraft, obviously 4 engines, and you ever look at the exhaust streaks on it, some of them on the outboards of the engines are different exhaust patterns where it goes over the wing, some goes under the wing. So you end up with a nice collection on Lancaster. So you get some going over the wing, and you also get some going underneath the wing as well. So when you get all that carbon deposits from an engine, it all sits on the wing of an aircraft, and then the aircraft's left outside, say, at inertia or whatever, and it hammers it down with rain. A lot of that carbon deposits mixes in with the water, and it gets underneath the skin. It gets in all the little nooks and crannies. Same with underneath, so the nacelles underneath the aircraft, where the inboard ones is where the wheels go up into. Outboard ones, not as much, just got your oil tank fairings and stuff. They collect all kinds of carbon, crud and all kinds of stuff. So they're quite prone to get a bit of corrosion if you're not careful. And we found that with ours, it's no different. It's no different. So you end up getting that, and that's where a lot of the problems lie as well.
Can you prevent that in any way?
You probably could, but it's be a labour intensive, be washing it every 2 weeks, no doubt. You know, I think they're doing a lot of cleaning.
Is that better than
Oh, it is, yeah, of course it is, yeah.
prevention
No doubt.
rather than cure?
Yeah, of course it is. I mean, a lot of aircraft are wet assembled anyway. What I mean by wet assembled, some of you probably already know. When you put 2 pieces of metal together, we had JC. It was a yellow paste. It was like JC5. It was called. It was like a lacquer sort of something. It was a paste. And what you would do is you get 2 pieces of metal that you want to rivet together, that you know is going to be exposed to the elements outside, top of a wing or whatever. And you would put this yellow stuff on, put your other panel over the top of it, rivet it together. And that acts like a weather seal, really, like a seal. Just stop stuff getting in underneath. So that's what you can do, you know, and that's what we'll be doing with Just Jane. I mean, Jane's, the corrosion in Jane's north section wasn't as bad as we thought it would be. So you can imagine the aircraft sits like this, and when it hammers it down with rain, the perspex, you know, there's nooks and crannies everywhere water gets in. It all collects in the bottom, it sits in big puddles, and that's where you get a lot of corrosion. So that's why you need a lot of drain holes on the aircraft. They also need to be kept clear as well, so you don't get these puddles forming inside that drain over the water off. If you keep drain holes clear, you can prevent a lot of corrosion just by keeping the drain holes clear. Or do what they do with the Spitfires, put them in the hangar all the time. You know what I mean? Don't leave them outside in the rain. So yeah, so that's where we are with that sort of stuff. Recently, we've got asked to do the flight eng. I've never done it before. I mean, I've run Typhoons when we've done engine changes on Typhoon jets when I was on the squadrons. Lancaster, I've never done anything like that before. So they said, you know, do you fancy getting involved with the flight eng? So we have a pilot, sits in the left-hand seat, qualified pilots that turn up at this journey. A lot of them ex-forces pilots or ex-army. So they'll do the taxi around, doing all the steering and all this rudder pedal and malarkey, going around the fields. But the flight eng is responsible for the engines. So starting all the pre-flight checks. So do what pilot does around the aircraft, do walk around checks. And then you would do you would get in the aircraft. So this is how I would do it, how everybody does it. Get in the aircraft. As you're walking up the airplane, there's a battery switch, a ground flight battery switch, it puts batteries on. You turn that on, climb over the rear spar, and then you've got your front spar, and then you've got your fuel cock. So you turn your fuel cock on, which allows your fuel supply from your number 2 tank. So because the left wing, as I mentioned earlier, is French, we've not swapped all the fuel tanks on. So this aircraft, well, ours doesn't have 6 tanks. We've got 6 tanks, but not 6 tanks fitted. So we've only got 1 tank fitted, which is the number 2 tank in the right-hand wing. So what we would do is we turn the fuel on. That allows the supply then from fuel, from the tanks, obviously, to the pumps and everything, to the engines. Turn the fuel on, turn power on for the flight eng panel, which is on your right-hand side as you're going in. Turn that on, and then you would turn there's a small panel with it, it's got your coolant gauges, it's got your radiator temperatures, it's got your oil pressures, all that kind of stuff. Turn power onto that, and then turn your fuel cock on. Turn your fuel cock on. Once you've turned all that on and all that's all sorted, then now you're dealing with the front of the dashboard, should we call it, the cockpit. You've got your boost coil switches for your energising your boost coils to start the engines. You've got a flat switch and you've got magnetos. Magnetos have got 8 switches. You've got two magnetos for each engine. It's a redundancy for if you lose a magneto while you're flying in an aircraft, a Spitfire set, it's got 2 magnetos. If you lose a magneto, you still fly the airplane, you know, so you do mag checks. Mag checks, basically, it's you confirming that both magnetos for your engine are working. So what you would do is, while your engine's running, you've got both mags are on, turn left mag off. Once you turn it off, you'll see the RPM drop slightly. It's still running because another mag's on. Then turn that mag back on, do the same with the other one, see the RPM drop. Then what you do is you do like a dead mag sort of thing, like a dead check. You turn them both off. But you only do it briefly, because when you turn them both off, and you left them off, the engine will stop. So when you turn them off, do you ever watch the video of the Lancaster, any of them, BBMF saw this one, when you hear the engine running, obviously it stops and starts again. That's them doing the checks on the magnetons. So what we do then is go up and we check all the switches, make sure the switches are safe. And then the guys downstairs, the volunteers, I'll get onto them in a bit, right at lunch, they will prime the engines. So they go up on the inboard engines onto the wheels, and you've got manual priming pumps, car gas primers are called. So what they would do, they'd get up in the undercarriage bay when they're ready to prime. And there's two levers, so there's inboard and outboard. So inboard engine, outboard engine. Do your inboard engine, turn it up, so that allows fuel supply then to be drawn from the tank and then pumped. So the car gas is a plunger, draws it in, and RV shuts, fires it off the other way, takes it to the engine. So they would prime it. Once they've primed it, turn it off, do the same with the outboard engine. That's the engine's primed, so they do that both sides. Once it's ready, then we're ready to start the engine then. So we check our RPM levers, check our throttles, and then we're more or less ready to go then. Open the throttle a little bit, turn fuel on for that respective engine, hit the boost coil switch, hit the start switch, engine will turn. As it turns, get about 3 blades, turn your magnetos on, get ready with your throttle. It coughs up into life and that's your engine is running. So that's what we started doing. I've never done anything like that before. So then, once we've got all the engines running, we do the checks with the magnetos, like I mentioned earlier, all 4 engines, so they all get checked, then we go out into the grass. Do the taxiing round for the public, and then we go to the end of the strip. This is interesting, this bit. You go to the end of the strip, you line up, and then you've got to put all 4 engines up to 2,000 RPM. It sounds bad, and it sounds a lot when you listen to it, but it's nothing compared to what the engines are capable of. I mean, imagine this thing taking off. What was it? 74,000 pound take-off weight in 1945. So you can imagine the power required to get that off the ground. You know, and we're thinking at 2,000 RPM, what we're doing is a lot. It's peanuts compared to what it's capable of doing. So anyway, we get all 4 engines up to 2,000. Check all the pressures. Oil pressure, critical. You've got to check that. If you lose oil pressure, you won't get it. And that'd be it then. Off we go down the grass strip. All the people in the back love it. You know, go down the airfield, pull the throttles back, and then we taxi back in. Before we park up, we'll do a CSU check, which is the propeller. So people are familiar with variable speed, constant speed propellers and variable that kind of stuff. So what we'll do is we'll exercise that system. And basically what it's doing is, as your propeller hits the airflow, the angle of attack that it hits at determines how fast the engine's going to be running, how much power it's going to, how much thrust it's giving. So what we'll end up doing is put the inboard engines up to 0 burst, which is something like 2,300, 2,350 RPM, and then you exercise these prop levers. And as you move them up and down, it changes the course of the propeller blade, which then brings your RPM down ever so slightly. And you can actually hear it doing it, and we exercise those, so you'll see that. If you ever watch Just Jane Taxi, you'll see how to do that on the engine. And so, going from somebody that, from my background, from jets, with a spell on being left a million years ago, coming to East Kirby, getting into a Lancaster, and taxiing it down the field was just unbelievable. You know, I mean, a couple of weeks back, I was just leant out the window. Well, we were taxiing along, obviously everything was fine. And I thought to myself, God, I can't believe I'm actually getting paid for this. You know what I mean? You know, I'm just leant out. All the people in the back are loving it, and I'm just hanging out the window, and I've got 2 engines here. We're just trundling around the field, and pilot is happy as Larry. And I thought to myself, you know, it's a bit surreal, really. You know what I mean? My granddad was an armourer during the war on Lancasters, and he was based at Waddington. And I thought to myself, God, if he was still alive now, he would probably believe it, wouldn't he? You know what I mean? So, look, I'm hanging out the Lancaster. He's been taxiing around like laid him up, you know. But yeah, so that's another aspect of the job that I've been doing lately, just doing the taxi runs. So, is there anything anybody wants to ask? Any questions? Anybody got anything?
Yes, please.
Yeah, go on.
You talked about the mag drop there.
Yeah.
I've heard of it before, but it's always puzzled me. If you've got an engine running, both mags are okay, why does the RPM drop when you switch one off?
I think it's down, so there's an inlet and an exhaust magneto, and they do one side of the engine, the other side of the engine. And I think, see, because I'm a legacy airframe technician, not an engine, like I said, I'm quite new to this. But obviously the book tells you that expect like a 50 RPM drop in, I don't know, honestly, if I had the answer to that, I've no idea. You know what I mean? I don't know, they never told me that bit. They just said, expect round about 50 to...
Sorry.
Yeah, no, it's fine. It's a valid question, isn't it?
Yeah,
Hopefully somebody will find the answer. But yeah, so that's what we'd expect. A magneto drop. Yeah.
Innocent approach to it is you've got two mags in case one
But
of faulty.
I suppose the magnetos have got to throw, I mean, both of them working together have got to kick out a constant power, haven't they? And I suppose if you've only got, if you've got two generators operating, I'm not an electrician either, I'm not telling you. You're probably close to that with all your radio stuff, but if you've got two generators running, keeping a light on, and you turn one generator off, I'd like to think the light's going to go dim a little bit, wouldn't you? And that's the only logic I've got for that. Unless anybody can think of anything else. No, I don't know, honestly. I'll find out for you. I will, I'll find out. I know there's a guy, let's call Brad. And what he doesn't know about the Merlin engine, he should be studying, I'll tell him that engine. I'll ask Brad, and then what I'll do is I'll get in touch with Phil. Phil can come and say, I'll
It
tell
seems to
you.
be the thing with all engines. You know, there are red books from way pre-World War II. They still talk about mag checks.
Mag checks,
And mag drop.
Yeah, it
seems to be, it's something that's expected. And
something expected, but nobody actually tells you why. Like I said, some people can just read books and get given some information and just believe it and go on, but some people go, but why? Do you know what I mean? And I'm a little bit like that. You know, but why? Why is it? I don't, honestly, if I knew I'd tell you that, I have no idea. But that's what we expect. We expect a mag drop. Not a massive one,
no.
just a little bit of one. You know, if you get a massive one, we had an issue, and the reason we do these checks, we had an issue where you could get a live mag. So you turn the mag off, and the engine's still running. So when you expect an RPM drop, when you turn the magneto off, and the RPM doesn't drop, and you turn it back on, and you turn the other one, and you can end up in a situation where you turn them both off, it's still running on one magneto. Do you know what I mean? Yeah. So when you cut, because we cut the engines with the fuel, we don't shut engines down using magnetos. We just go to the master fuel cocks, and we close all the fuel cocks. Once the engines have stopped turning, then we turn all the mags off.
Yeah.
But if you've got a live mag, even though you've turned them all off, potentially you could still have a magneto that's live on one of the engines. So if somebody were to go along to it and just grab hold, instead the blades are not lined up straight, and you got hold of it and swung it, it could potentially kick up. You know what I mean, and give you a clip round the ear, or, you know. Well, it could do, couldn't it? That's what I reckon. Yeah, so has anybody got any more questions?
Has anybody actually worked out the materials that there was built of, like the magnesium rivets and everything else? The current versions of them are a lot stronger, a different manufacturing technique.
Yeah.
What's the weight difference between the replacement parts and the original parts? They're probably a lot stronger now than the originals ever was. But overall,
there is
there's going to be a cumulative weight difference. It's going to be heavier or lighter.
It's going to be heavy. It's definitely going to be heavy. Yeah, of course it is. It's
not always the case. The newer stuff is stronger, but it's lighter. But has anybody worked out the calculation across the board?
Yeah.
What it's good
Well, some of the material that we use, like T3 and stuff like that, you know, the kind of material we use and the material thickness is some of the stuff that you could get back in 1945, 1940s. They don't make it anymore. You can't buy it in sheet meat. You can't buy sheets of that material anymore. You can't even buy it in that thickness.
No.
You know, like a certain material at 20 thou or 21 thou, and you just can't buy it anymore. So you've got to work up. You can't work down. If that makes sense. You can't go thin. You've always got to go thick.
Well, the materials back then was basically pig metal, that there was scavenging metal from wherever it could to make them.
Exactly.
So
And
it was poor quality metal.
Exactly.
It was all they could get hold of.
Yeah, and it lasted 18 years. Yeah.
So the newer stuff.
Yeah, so the newer stuff, yeah. I think we're finding that some of it, we've always got to go up couple of thou rather than go below, if that makes sense.
You have got the advantage that you're not carrying 10 tonne of bombs.
We're not carrying 10 tonne of bombs.
10 tonnes?
And what's the bomb bay going to be set out for? Barnswell, that's a traditional bomb.
Oh, it'll be a traditional bomb bay, yeah. I'd say heavier, but we've not got, like he's mentioned, we're not going to be flying around with 2,000 gallons of fuel on board, thousands of rounds of 303 and a full bomb load on it with a 4,000 pound blast bomb in the middle. So it'll still be quite nimble, won't it? I think.
Getting back to your complications with the panelling and being a different shape, my son-in-law would empathise with you because he was the lead architect on the Lancaster, the A46 there.
All right, yeah.
And he was saying he did his head in. Every single panel, every single piece was different from the last.
Yeah, of course.
As everything tapers, doesn't it?
It does. And that's
It's a nightmare for
It is. If you, I don't know if anybody's familiar with Nev Wielden. He's a guy that's done a hell of a lot of video work at East Kirby over the last 10 years, maybe longer. So he's documented. You only mentioned in 2016 that they'd stripped the aircraft back down to Burnett. Well, he was there to video it. So there's video footage of it. This silver Lancaster in his hangar. So Nev's been doing a hell of a lot of work. He used to come quite regular, sometimes twice a week, and he would go around everybody. So obviously there's Keith on the wing, me on the nose, some of the people on the tailplane. He'd go down the bottom end to see what the volunteers were doing on the bomber. Or he'd stick his head in with a B-25, if anybody's familiar with the B-25. We've got one of those at our place that the lads are putting that together. He'd stick his head in that. So if you ever look at Nev Wielden's videos, there's tons on it. And he asks questions about what we're doing and how we're doing it and why we're doing it. So when people are watching, they can sort of get an idea of what we're doing and why we're doing it and why we're doing it, the way we're doing it, if that makes sense. So if you ever stick your head on YouTube and just look for Nev Wielden and just type in East Kirby videos, you know, they'll probably come up. But he's quite a character really. And we don't wind him up, but we try and drop a few little innuendos in as we do. You know what I mean? Because he's like 80-year-old. We try and sneak a couple of cheeky ones in and hope he doesn't get them. We sit there like kids, and then when the video comes, it's in. You know what I mean? Laughing at his childish.
How many of you working on the project then?
So full-time structural engineers, so the people involved with the structure side. So there's myself, there's Jody at the back, Josh, who's a youngish lad. Now Josh came over from the Midlands somewhere, and he's just passionate, he just wants to work on aircraft. So he packed up from where he was, came to East Kirby. He's loving it. So Josh as well, young lad. Keith, as I mentioned, and myself, and Dave Moulds. So Dave is ex-RAF as well, but he was workshops. So there's 5 of us. So Dave's ex-workshop. So in the RAF, we had a workshop section. And that's not making sheds and stuff like that. People using CNC machines and lathes and shrinking and bending and stretching metal and that kind of stuff. So Dave's been quite instrumental really in getting a lot of us, getting our heads around some of this metal shaping stuff. Because like I said earlier, it was new to me. But for Dave and Keith, Dave primarily, showed me how to use the shrinkers and stretchers. So there's 5 full-time engineers, but we've got quite a few volunteers. So we've got a couple of volunteers that come and they purely help out with the structure side of things. They normally come twice a week, getting involved, helping out where they can help out. I know we've got a guy called Terry. He comes in usually twice a week. He's helping out with the wind deflector. So on the back end of the Lancaster where the rear turret is, there's a wind deflector. So that if you're facing backwards out your rear turret, this thing comes up here, and it stops a draft getting round the back of the turret. If that makes sense. It's like a fairing sort of thing. It's quite a complex shape, this fairing. So he's involved with that. Him and Norman are involved with that to get that put back on. So they're doing that. So we've got the volunteers at that end, but the volunteers that we've got that do the taxiing, they're just instrumental to that place working as efficiently as it does. You've got quite a few old hands that have been doing it for quite a while, volunteering to do the taxi runs. So there's me and Jodie does it, there's 2 other lads that do it in the hangar, but we get volunteers come in and do it as well in the spare time. And we've got quite a few volunteers that come down religiously. Some of them travel quite a distance, you know, to get to our place, and they'll be there all day. I mean, we've got an air show coming up this Saturday, and I think we'll probably be kicking off starting around about 7 in the morning to get the aeroplanes out. And these volunteers will turn up like clockwork and they just get on with it, you know. We've got volunteers that do the ground crewing for the bomber, so they're the ones that I mentioned earlier, like carrying out the priming and all that kind of stuff. They do the marshalling, they do the safety crew. So if you have, we've got a fire team down there all the time. So if you have an incident with the aircraft out on the grass and everybody needs to get off it, the volunteers, along with a full-time lad, they'll man the vehicles so they can get onto the field, get people off the aircraft in a safe manner. And we've got a fire crew as well that can tackle any sort of issues we've got with fire hazards and stuff with the airplanes. So it's quite a big volunteer footprint, really. And I think, honestly, without it, we'd not be able to do a quarter of what we're getting away with, what we're doing at the minute. In terms of taxiing, same with working in the hangar, people just coming in and just generally tidying the place up, keeping on top of things. We've got guys coming in we've got people coming in doing the gardens, doing the tree. You know, there's a lot of trees at East Kirby, and they've all got plaques on them that commemorate WAFs from years ago, and pilots and ground crew and all kinds of stuff. And it all needs looking after, you know. So we get volunteers coming in and they just do all that. So if you ever go to East Kirby and have a look at it, it's well kept and everything's looked after. It's all tidy. The hangars are the same. You know, we've got people come in and just make sure everything's looked after. All the artefacts that we've got, there's people that maintain those and look after those. We've got an Hampton that's being restored. There's a guy called John. He's got an Hampton project that he's ticking away at on his own in the Bolingbroke. So yeah, so it's quite a busy place, quite a lot going on really behind the scenes just to keep it all going, you know. Anybody want to know anything else? Have I missed anything? I probably missed loads, haven't I?
Thank you.
Yes.
Oh, that was absolutely fantastic talk. Thank you very much. Much appreciated.
Anytime.
Round of applause. Thank you very much.
Just mind your glasses.
Yeah, I've been inferior. I've started down to ground, so we've got quite good.
It's been done by one.
Would any of the against would like to do
Something for thinking.